Hi everyone, good evening. Let's start. Am I audible? Guys, am I audible? Can someone quickly tell me? Okay, great. Cool. So yesterday, a quick revision of what we did yesterday, right? So we started with something called as the prototypal chain, right? Or the prototypal inheritance. So we majorly discussed about one concept, and we'll just try to close that concept today, right? So just will quickly take you guys through it. Cool. Am I audible, everyone now? I just switched my connection for better coverage. Right. Okay. Perfectly audible, right? Good. Good. Okay. Yes. Okay. So we started with something called as prototype chain, right? So the first question that we tried to answer is, let's say I wanted to create a dog, right? And this is in context that we've already created an animal class or an animal constructor function, either way. So we wanted to create a dog, but very soon we realized that if we want to create a dog, we'll have to repeat certain things, right? One is function dog, right? All of this thing here. And then we say dog.prototype.eat, rest, sleep, bark, whatever, right? And using this, I created my new dog, right? But very soon we realized that this is a problem because eat, sleep, and rest are three properties which already exist on an animal, right? So if we were to take this approach, then for every type of animal, be it a dog, be it a cat, be it whatever, right? We are going to have to create separate classes, separate prototype methods, and everything separate for these guys, right? Which is certainly a waste of memory, right? And we saw this when we try to create a cat, right? So all these functions were getting created again and again, right? Everyone understands the problem, guys? Yes or no? Okay. Then we quickly copied the animal class, the existing class, right? And now we moved on to another important concept, which is the concept of this in JavaScript, right? The concept of THIS, right? And for that, we learned something. We learned another mechanism of calling JavaScript functions. So we can either call JavaScript functions as we normally call them, or we can use dot call on the name of the function, right? And what that does, it allows us a means of attaching a new THIS in that, right? Or binding a new THIS while calling that function. So in here, what we did now when we were calling new dog, right? At the same time, I called animal with the THIS of dog, right? And when we did this, yep, when we did this, the problem was solved. Why? Because now this animal is getting called with the THIS of dog, right? Which means animal is going to get that this, which is the this of dog or the dog this, as we mentioned yesterday. And on dog this, we are going to attach name and energy, and we are going to equate the same to, and we are going to add name and energy to it, right? Which was called like this, right? Finally, we attached the breed, which is the uncommon property. So now for common properties, it's very simple. You are able to call them like this. For uncommon property, slightly different. You just attach it as you would do anything else. Finally, two more steps. Step one, delegate all field lookups on dog.prototype to animal.prototype. What that will do is dog is going to get access to all of animal functions, right? And similarly, we realized while doing this, the constructor, the prototype.constructor will also get overridden to the animal constructor. And using this line, we rectified the same. So now we said dog.prototype.constructor is dog, right? And finally, whatever other methods or specific dog methods we wanted to apply, we applied it on its prototype. And that's how we created our new dog. Everyone clear with all of this? Guys, any doubt? Anyone? No doubts? 1476 again. So when you did doc.prototype is equal to object.create this, what is going to happen? This is going to return an empty object, right, Ravi? So doc.prototype is going to get set to an empty object, correct? Where all field lookups are now going to happen on animal prototype. But while doing that, since we've delegated everything to animal prototype, when we try to look for doc.constructor, that field lookup of constructor property is going to happen on animal prototype, which means the prototype, the constructor has got overridden. So how do we fix that? We specifically say doc.prototype.constructor and point it to dog. Now clear? Okay. Okay, guys. Let's move forward. However, now we want, let's say now we wanted to do the same thing using the class keyword, right? So up until now, what we've done, we've just accomplished the same with prototypes and specially mentioning this, but with functions, not with classes, right? Now let's see how classes can make this job very, very easy, right? So I use the class keyword. I say class dog. So I'm just going to move this to class, okay? Let's see how we do that. I say class dog, correct? Inside that, again, we are going to have a constructor, right? Let's give it 3 properties, namely name, energy, breed, right? Inside this, we specify this dot breed, right? And dog in itself is just going to have one function, which is called nothing but bark. And this part just says console.log. Okay, that's it. Guys, did you understand what we just did? We have simply written the same thing using a class, right? And we already have the animal class. So let me just copy that animal class instead of rewriting it. Class animal. Okay. So now we have class animal and we have class dog, right? Now the question that should come to us is how we can do this pairing here, right? Okay, so let's understand one important thing. Now that you have your animal constructor written as the ES class and the dog constructor also written as the ES class, the very easy or a very straightforward way of doing this is using the extends keyword, right? Please understand this. So what we are doing is we want dog to inherit all of the methods which were previously being consumed by the animal, right? In a way, whenever there is a field lookup for common properties, we want that field lookup to happen on animal, right? And to accomplish the same, we use the extends keyword. So very simply, if in front of this you say extends animal, right? Very simply, if you do this, everything is taken care of you, right? Did you guys understand what I said? The moment you do this, guys, whenever now you are going to create all of this for us. Am I not audible? I don't know why this is happening here. Let me, okay. Please let me know immediately, right? Let me know immediately if it's breaking. Okay, now it's breaking. Okay, I'll just change my connection again. I'll change it to my hotspot. Please give me a second. Folks, I'm here now. Can you hear me? Is there a problem still? Yes or no? Is it better? Did it get better now? Better? Okay. Okay. Cool. Then we shall move forward. Right. Extends for inheritance is last where we stopped. Yes, Pratik. So what we realized is, yeah, that's what I'm telling you. There was a dog, there was an animal. For getting all of the properties of dog, we did two things. One is we did this, we called animal internally, animal.call, this name and energy, right? And these properties got attached to the dog ka this, right? Then what I've done here is I have created an animal class and I've created a dog class, right? When I just animal here, right, saying extends animal here, and what this is going to do, guys, my god, what is happening today? Guys, are you not able to hear me? Arey RV mein, I'm not doing this on purpose na baba. Okay, it's breaking very much. Let me check my connection speed if that's a problem. It should be much better now, guys. Right? I've just done something. Okay, now let me know if it again happens. Okay, I'm guessing it's better. I've just moved closer to my router. I'll just move closer to my router. I think it's a connectivity problem, voltage of the router. Okay. Now I'm just going to repeat everything I said. Okay, and please keep telling me if it happens again, right? Cool. Did we understand this part, everyone? How we were creating a delegation on failed lookups to animal prototype for dog. Did you guys get this? So in some sense, we were able to extend the capability of all animals to dog. So even when we create a new animal, it becomes very simple for us, right? Cool. Now what I'm telling you guys is another thing. That thing is, whenever you say extends animal, right? The prototype delegation is automatically going to happen for you. Please understand this. When you say class dog extends animal, then these two lines will be taken care of, by the syntax by extending animal. Clear? Everyone, is this clear? Is this part clear at least? Right? Now, what this thing will not take care of, guys, what this thing will not take care of is calling the animal class and setting the properties on this. Right? So it is not, it's basically not going to take care of this part, the extend syntax. Did you guys understand? Because it's very natural also, if you look at it carefully, nowhere in this code are we actually calling the animal class. We have simply said extends animal, correct? So how can we fix that? It's very simple. Please understand what I'll just do now. So are you looking at the constructor function of animal? Is this visible, guys? Right? So what we need to do is internally, somehow we need to call this function. Okay. And how we do that? Let's quickly understand that. When you use the extends keyword, JavaScript gives you another keyword, which is called super. Right? And what does super mean? Let's understand that. The dog class is extending the animal class. We know this. When we call super, it basically makes a call to the constructor of the extended class. Right? Please understand this. What I'm going to do here is I'm going to say super name energy. Right? Super name and energy. It's going to call animal classes constructor, but with the this of dog class. So it's exactly identical to what this guy does. We'll type it here. This guy, animal dot call this name energy. Okay. So calling super with name and energy is going to call the constructor function of animal class. And you know what that constructor function does. It just attaches these two things to the this. And that's all we've done. Finished. Is everyone clear? Is there a doubt? So all of the complicated things that we did above of object.create, dog.prototype, dog, and all of these things, they are all covered just by writing this one line. Okay, the need of super. See, Amit, when you say dog extends animal, right? It basically means that these two things have internally happened, right? That is one, the assignment to the animal prototype, right? And the fix, this correction factor which we had to apply. These things will automatically be taken care by the extends keyword. Now, the second step that you need to do, if you look back on what we did yesterday, was this thing, right? Attaching these two properties to the dog. How we do that? We use the super keyword. What does super mean? So basically, this is the base class or dog class, and this is the top class. Animal is the base class from which dog is extending. So in some sense, dog is an extension of animal, correct? By saying super, we are calling the base class ka constructor. And what is the base class ka constructor? It's this function. So when you call super with name and energy, internally it's doing this. I hope it's now clear to everyone. The use of super and extend. Right, guys? Right, everyone is clear? Okay. Okay, great. Guys, with this, we have formally completed. Can I use animal.call in class dog extends? Why will you do that? Ajay, kar to sakte hi ho. It's a valid syntax, but you should not do it, right? When you're using classes, take advantage of classes. Guys, are we done, everyone? Is there any doubt? Please ask. Because with this, we formally conclude prototypes, prototypal inheritance in JavaScript. This is what inheritance is, right? When the dog class inherits the properties from animal class. We'll just take 2 minutes, and if you guys come up with any questions, please ask. Otherwise, we'll move to the next topic then. How many types of inheritance? What do you mean, Shivam? What is the other type of inheritance that you know? See, in JavaScript, all type of inheritance happens through the prototype, right? Essentially, this is what inheritance is. So the nature of inheritance in JavaScript is called prototypal inheritance, which we learned yesterday. So guys, essentially what we learned yesterday, this part is just an easy way of doing that, and that's it. When using dog extends animal, dog will also access the prototype of animal also in. No, see, Ravi, I don't think that's a good question, right? Understand this. What did I tell you? When you say extend keyword, extends keyword, it basically does these two things. So the prototype of dog essentially becomes the prototype of animal. So I'm not getting your question still. He means can dog have what? Of course, right? If dog has the access to animal prototype, all failed delegations that happen on dog's prototype are going to get carried over to run, rest, and eat. That's what we learned yesterday. Today, what we are learning is nothing but a better way of writing it, or not even better, a different way of writing it. So guys, please don't get confused. Today, what we have just learned is how we can write this thing in an easier way. That's all. That's all we've learned today. Still any doubts? Clear है सबको? Right? Okay, then I'm going to move forward to the next topic, guys, if this is done for you. Okay, with this in mind, right, we have pretty much covered most of the things that are to know about objects, right? Creating new objects and inheriting properties from other objects, right? This is what we learned in the past couple of days. Now we are in a place where we need to move to the next topic, right? And what is this topic, guys? This topic is something known as async JavaScript. Right? Now we are going to move to asynchronous JavaScript. Right? Before I do that, does anyone know what the word async means or asynchronous means? Does anyone know what that word means? Before we know what it means in terms of JavaScript. Someone must be knowing here. Non-serialization? That makes no sense. Rajat? Merge? क्या बोल रहे हो भाई? Nested function? Nahi, nothing like that. Processing in parallel. Okay, now we are getting somewhere. Not really. Not true, Shubham. Okay, Pradeep and Pratik have some good points. Okay, cool. Now let's understand what it means, right? So guys, you might have heard these things. Work randomly. I gave example of async. Not completely true, Dheeraj. Okay, let's understand this. Right. So one thing that you might have heard time and again is that JavaScript is a single-threaded programming language, right? Have you guys heard this? Have you guys heard this? Right. So what does this mean when we say, hey, JavaScript is a single-threaded language? It means that JavaScript at a time can only perform one operation, right? Right. So what does that mean again? Like it means that if you are performing one thing, you cannot perform the other thing, right? For example, while you were going through the array, iterating the array, you cannot do anything else, right? So this is in a way simple. It makes the language simple in terms of understanding the language, but with that, it brings certain limitations also, guys. So in other languages, in other multi-threaded languages like Java, what happens is you can spawn or create multiple threads, right? And basically, that's where actual parallelization happens. So those languages can really use your CPU, the multiple cores of your CPU, and do multiple tasks at the same time, correct? But in case of JavaScript, that is not true. While it is performing one task, it will not be able to perform another task, right? So the advantage is it simplifies the writing of code because you don't have to worry about concurrency issues, right? And what are concurrency issues? Basically, when two threads, right, or two things are happening in parallel, you need to take care. You need to handle them. You need to handle them explicitly, right? Otherwise, just consider one example, right? Let's say there was an array, right? And there is some element which is trying to read the array and make changes to it, right? So let's call this one element, right? Or let's call it P1, which is thread one, right? Which is basically taking this array and making some changes to it. Let's say multiplying the numbers by 2, removing this number, adding numbers, all sorts of things it can do, right? And there's yet another thread which is accessing the same data structure, right? And this guy can also do its own thing, right? It can remove elements, add elements, whatever, right? Now, if these two things were to happen in parallel to one single data structure, what is going to happen, guys? Collision is going to happen, right? Maybe this guy made changes to this element of the array, and this guy also made changes to this element of the array, right? So what are these? These are concurrency issues. Concurrency issues, right? Essentially meaning that two threads working on the same data structure, which is array in this case, and they can corrupt this data structure, right? So in one example of concurrency issue is data structure corruption. Did you understand how if two things are happening in parallel, they can actually destroy a data structure? So at the end of this, you might be expecting one result, but because of this, something entirely different happens, and you get a completely different data structure, right? Right? Okay. So like Pratik mentioned, the waiter example, or someone said waiter, right? So guys, what does that example mean? So it's a very common example that people use to explain these things, right? So I'll also use the example because it works. Okay, imagine there is a restaurant, okay? And in that restaurant, there are multiple tables, right? Now, imagine there are multiple waiters also. So let's say there were 100 tables and there are 5 waiters, right? Or let's say there are 10 waiters, right? Now, consider this problem. It's a very common problem. Let's say one table, right, is being served by 2 waiters, right? One table in the restaurant is being served by two waiters, right? Different waiters. If those waiters do not interact between themselves, let's say to waiter 1, you say, hey, I want item B and C, right? While the waiter takes down your order, the other waiter also comes, and you tell them that you want B and C, B and D, and cancel C, right? So instead of B and C, your order is now B and D, right? Now, if waiter 2 does not relay this, does not tell this information to waiter 1, what is going to happen, guys? You are going to get 3 dishes, B, C, and D. Did you guys understand? Right? So while having multiple waiters can help you do many things in parallel, right? So let's say there were 100 tables, 10 waiters. If they are able to intelligently divide the tasks between them, then each waiter can basically have 10 tables, right? And waiter for table 1 never interacts, let's say, with table number 56. And that is only under the purview of waiter number 6, right? So by using these techniques, I mean, I wouldn't get into the depths of these techniques because multi-threaded programming, parallel programming are not really part of our curriculum at the moment, right? But just wanted to give you guys give you guys a hint how it works, right? If they synchronize, then it will help. Yes, if those waiters are synchronized amongst themselves, then they will not corrupt the data structure. I mean, I'm not sure if you guys are learning Java, I think in DSA, but that's where this concept is going to come, at least to some extent, right? Synchrony and okay, I won't get in there. Never mind. Good. So we have this, right? So Java as a language is an example of a restaurant with 10 waiters or more waiters. How many ever waiters you want in Java, you can spawn those waiters, right? But guys, in JavaScript, what is going to happen is there is always going to be one waiter. So even if there are 100 tables, even if there are 1000 tables, there is going to be a single waiter, right? And what does that mean? Let's say table 1 is giving its order, right? So while table 1 is giving its order, table 10 or table 35 cannot give its order, right? Because one waiter can at a time only do one task. Did you guys understand? Right? Okay. Now let's just take this waiter example a bit further. Okay. Let's say the waiter has to take order, right? The waiter has to take order from a customer, and then there is some mechanism using which it has to give this order to the kitchen, right? For it to get prepared. But sir, how they consider the table? I mean, which table will serve first? Arey, Sweta, that's a different question now, Baba. Right now, try to understand the concept. Oh, don't ask these questions. Just wait for some time here. So what am I saying? What I'm saying, guys, is JavaScript. Imagine JavaScript is that waiter, right? And it's trying to give those orders to the kitchen, right? Now imagine that kitchen is the browser, right? or it's the whole restaurant, howsoever you want to think this. The point is JavaScript is one worker, or this waiter is a worker of the whole restaurant, right? So what is the job of that worker or that waiter? The job of the worker or the waiter or JavaScript is only to take orders, right? And not actually cook them, right? So how it's going to work is the waiter keeps taking orders, and when it takes an order, it gives that order directly to the kitchen, right? Now, when kitchen has prepared that order, right? What kitchen guys are going to do? They are going to call back or tell the waiter that, hey, the order is ready for table number so and so, right? And since we know JS or this is only a single threaded waiter or a single threaded language, at a time, the waiter will only be able to return one result back, right? Or only be able to give that food or that order to one table. Did you guys understand the example? Right? So did we understand the limitation? The limitation, right? Or the thing which is making this easy also to understand is that there is only one waiter, right? Whenever it has to do some work, it does either it can do the work by itself. So that is basically an example of taking orders from the customers. That is one work that the waiter has to do sequentially, right? So take order from table 1, table 3, 5, 37, whichever table, right? So it has to wait, right, guys? When, let's say I'm the waiter, right? When I'm taking an order from someone, I have to wait on the table, right? And I have to spend some time taking that order, right? So an example where I'm actually waiting for the result, or when I'm waiting for something to happen, is called a synchronous or sync task. Did you guys understand this? What is a sync task? In which I have to actively wait, right? So while I'm taking the order of table number 10, I have to patiently wait and take that order, correct? Great. However, when I have given these tasks, all of these tasks, right? So let's say I had to do 10 tasks. I take these 10 tasks and I give all of these tasks to the kitchen, right? Or all of the orders to the kitchen. Am I waiting on the kitchen, guys? Say yes or no. Am I waiting on the kitchen? No, you're not waiting on the kitchen. Whenever the kitchen is ready with the order, what do? They call you, they call the waiter, or they give a call back. Can I, in terms of the language, right? Right? So basically, JavaScript in itself is not capable of performing asynchronous tasks. It's the environment, right? Environment which is providing this capability. In this case, the kitchen workers. Environment which is providing this capability, right? So that's where the concept of asynchrony comes in. Right? Something which JavaScript does not have to do, it's going to get done by the environment or the kitchen in this case. And whenever the kitchen is done processing or done completing the order of the food, it is going to tell JavaScript that, hey, now I am ready, perform the task. Right? And what will be the task in this case? The task is going to be taking the food from the kitchen and delivering it to the customer. Again, that will have to be done in a synchronous fashion. Did everyone understand this? More yeses, guys. More yeses. Okay. Okay, then let's move forward, right? So, guys, while it removes overriding thing on function, Shivam, that does not make sense. आप जो भी बोल रहे हो, overriding का क्या लेना देना है इससे? Starvation is a problem on operating on processes, Sirjul. Here we are not deep diving to the level of processes, right? Starvation is a process problem. It's a scheduling problem. Whenever there are multiple processes and they are not able to get CPU time, that's what starvation is. In this case, there is no concept of starvation. Concept of starvation comes at the level of CPU or the processes, not here. Guys, I mean, if some of you have read operating systems, please don't confuse it with a process. This is not a process. This is not the 7-state scheduler model. This is different. Waiting involves till waiter doesn't take the order. See, again, you are getting into a different territory, Sweta, when you say this. We are not talking about waiting. We are talking about tasks which are lined up, right? We are talking about tasks which are lined up. So imagine already there exists an array or a mapping or basically a tasks which the waiter already knows. Okay, so let me simplify this so that this question does not come. The waiter has a slip in its hand which basically says which table to go to, right? There is no waiting here. Imagine the waiter is always occupied with something or the other. Any doubts, or shall I move forward? See, sync task basically means when the language or the runtime is busy doing something, right? Not when it's standing idle. That is not sync process because it's not even a process. It's not even a task. If you open the browser right now, right, not doing anything, right? I'm just opening my Chrome console. Right now it's doing nothing. So will I call this as a sync task? No. When something is happening, then there is a task. When there is no task, where is the question of sync or async? Tasks can be sync or async, right? When you're waiting means you're not executing anything. Are we clear? If no, please tell me, I'll move forward otherwise. Okay. Oh, okay. Now there are certain problems, right, that are there with synchrony. The problem with synchrony is, again, at a time you can only do one thing, right? With JavaScript, this really becomes a problem multiple times. Okay, guys. So I don't know if you've seen this. If I am to run some big task, right, on this terminal, right, or on this console. So what can be a big task? You can create a big array, right? Let's say an array of 10 to the power 7 elements, right? Please don't ask what these triple dots mean. I'll tell you later, right? And I'm going to create an array of some size, and I'm going to say 10 to the power 7, right? So basically, it's an array of 10 to the power 7 elements, right? And I'll just say dot map on that array, and I'll just fill numbers in it. So element index I, right? You guys got it? What I've done is, everyone clear with this? An array of numbers up till 10 to the power 7, right? Please see what happens. Please notice this again, right? When I press enter here, it takes some time for this guy to get displayed, right? I'll do it again. Please watch this very carefully. I'm going to press enter. Okay, now it had already declared T. That's why It worked. I'm going to create this element, this array, right? A new array, and I press enter, right? There is certain time after which this thing is coming. Did you see that lag, guys? Did everyone see that lag? Not sure if it's visible on the Zoom resolution, but and if the same thing you had done, let's say on this one, on say 100 array element, Chrome is Chrome, it's Chrome here, is automatically giving you the result here, right? Without you having to do this. So now when you press enter, it's right there. Guys, what I'm saying is when there is a big operation to be performed, and what is the example of this big operation that I'm taking? I'm taking creating an element array of 10 to the power 7 elements, right? And filling it with numbers using this dot map, right? When you're doing such a thing, there is some time which the language has to process this, right? So when I say 7 and press enter, there is some time it's taking, see? And only after that time, it is able to actually compute that, right? Guys, is the example clear what I'm saying? Please say yes or no, right? Now, if during this time, you tried to do something else, right? And I'll give you a very simple example. Don't ask that, I said that, I'll teach you that in the next couple of classes when I talk about the spread operator. Please understand, right now, this is just for creating an array of 10 to the power 7 elements. Cool. Anyway, now when you're doing this complicated a task or this CPU intensive task, as we call them, then JavaScript has to wait some time until this big task gets completed, right? Now, during the time it's busy doing this synchronous task, right? During the time it's busy for performing this synchronous task, because JavaScript is single threaded, it will not be able to do anything else, right? And what are the other things that JavaScript does? Everything that happens on a web page. So if you guys go to your Chrome console, let's say you open a website or something, right? And you try to execute this thing. Let's say you try to execute the 10 to the power 7 one, you will not be able to scroll the page, right? And why would that happen? Because scrolling on the page and basically getting new and new elements on the page as you keep scrolling down is something which JavaScript main thread has to do, right? So JavaScript only has one thread, which is called main thread, right? Because when it's busy doing one thing, it cannot do any other thing. So even if you, let's say, had your event listeners on click or whatever, right? You will, and let's say you are continuously clicking the button, you will not be able to see that result of your event listener. Why? Because JavaScript is busy doing this heavy task. And that's where the problem or the issue with synchronicity comes in. When I'm doing one thing, I cannot do another thing. Single-threaded language. I hope single-threaded is now clear to everyone. Right? Okay, great. Great. Okay. So we'll keep taking more examples and try to understand this, right? Let's first understand how the JavaScript, the JavaScript engine internally works, right? And I'm telling this in terms of in the context of running functions or running tasks, right? So I'm just going to write something here. So let's say I'll say const task one, right? Nothing but a function, right? And let's say it does something very simple. It says ran task one, right? Similarly, I create another task. Let's call it task two. Log task two, right? And let's do something here. Running task two. right? And in here, I'm going to call task one, right? Finally, I'll say task one, right? And for example, what you do here is you simply call task two, right? So if you were to tell me what are the things that are going to get logged, can anyone tell me in which order are things going to get logged? Guys, can anyone tell me what are the things when I call task two, what are the things that are going to get console.logged? Okay, so it's going to say running task two, right? It'll say ran task one, and finally it will say this guy completed task one, right? And let's actually say completed task two also, right? So what are we seeing? That when we run this function, first this happens, this happens, this happens, and then this happens, right? Right. So internally, how the engine does it is using two things. The first thing is something called as the execution context, right? Okay, so what is this execution context, right? See, guys, inside the engine, inside the JavaScript engine, what first happens is whenever you write a function, right? That function or this function, task two or task one, is basically occupying a space inside the engine, which is called execution context, right? And what does an execution context do? Consider it like this. It's one of the unit that the engine is processing, or the V8 engine or the JavaScript engine is processing. In that unit, a certain number of things are going to happen, right? So whenever you say task two call, it will create that container or that unit in which it's going to execute all of these things, right? Each function that you call, task two, task one, anything else, constitutes its own execution context, right? So in very basic terms, what is execution context? It's basically allocation of resources in the JavaScript engine, which are going to get executed. That's what execution context means. Are we clear with this? Right, okay. Second term, please understand this very carefully. This is called the call stack, right? So some of you guys might know what stack is, some of you guys might not. So guys, a stack is basically a LIFO, right? Is a LIFO data structure. And what does that mean? LIFO simply means last in, first out, right? LIFO means last in, first out, right? And that's what a stack is, right? If you look at it, what is a stack? Let's say I'm trying to stack one book on top of each other, right? And they were kept inside, they were kept in this container in which only one book can go at a time, right? अरे सिर्जुअल फीफो होता है क्यों यार, सुन लो ना. See, in case of stack, what is going to happen is, imagine there is a set of books that you are keeping one on top of each other, right? And the container is such that only one book can go inside it at a time, right? So let's say you had 10 books numbered from 1 all the way to 10, right? I first put the book number 1, then book number 2, book number 3, and I'm just going to go in series, right? So guys, which is the, and let's say I've put all the 10 books here, right? And at a time, I'm only able to pick up one book because there is no space. So which is the first book that I can pick out? Book 10, right? Because book 10 is the topmost book. So what is stack? Stack is a data structure which allows us to implement LIFO. So what the thing which is last in is the first to go out, right? Last in, first out, right? So guys, this is what a stack is. But what is the call stack? Call stack is basically where all of these execution context that I talked about are stored, and they are stored in a LIFO manner, right? Right. And JavaScript as a programming language has only one stack, right? Because of course it's single threaded. And this call stack has a LIFO structure, which means the item can be removed or added only from the top of the stack. This is what you need to know. Did you guys understand what I just said? Okay. So imagine, guys, now I'm creating my call stack using these things. Okay. Let's understand how JavaScript is going to internally work, right? So let's say this is my stack. I don't know how I'm going to draw this, but let me try that out. This is my stack, right? So once you execute task 2, right? What is your stack going to have? It's going to have task 2. Let me put it here, right? And there is nothing above it right now. So you call task2 function, task2 gets inside it, right? Then basically task2 gets inside it and JavaScript is going to start running task2, right? The moment it starts running task2, what is one thing that it encounters? It encounters this guy, correct? Guys, did you understand this? Right? So JavaScript is going to put this as the second part. Okay, now I have to make a bigger call stack. Let me make it this big. Okay, size for everything. So the second element inside this call stack is console.log. Right? And what is going to happen is as these things keep getting executed, they will keep moving out of the tasks, call stack, right? So you started task 2. Task 2 was started. Inside that, there was a console.log running task. And can this be executed immediately? Yes or no? Right? So what JavaScript is going to do, it's going to run task, it's going to console.log running task 2. Right? So basically, we will see this on our console. Right? In the next step, what is going to happen is this will move out of the task. It will move out of the call stack, or it will move out of the this thing, our stack, right? And what is going to push? What JavaScript is going to push is going to push task 1. Right? Okay, great. Now, when it's pushing task 1, it will whenever it tries to pull out task 1, right? Whenever it tries to pull out task 1, what it is going to do, guys, is going to push this guy, right? It's going to push this guy here. Because the time we are trying to run task 1, when we try to run task 1, we will encounter this console.log statement and we will run it, right? So in the next step, basically what happens is task 1 is going to get removed, right? So remove this, right? And since task 1 also gets executed, so remove this also, correct? Are you guys following me? Right? Next step, this thing is going to get pushed, right? Right? So this thing got pushed and it got executed quickly because there is nothing to go inside of it. So JavaScript executes it, logs it to the console, removes it, right? Finally, what does it push? It pushes this guy, right? It pushes this guy. Now this guy also gets executed. This guy is removed. Finally, guys, what happens? Task 2 is also completed. So it also moves out of the call stack. So what are you left with? Now you're left with an empty call stack. And this is where we say that the call stack is empty, or or JavaScript is sitting idle, right? So either you push a task into the call stack or you pop a task out of a call stack. Everyone clear? Right? Okay. So let's just talk a bit more about it. So guys, whenever the code is executed, right, what JavaScript does is it creates a global execution context, right? So we talked about execution context. It creates a global execution context, right? And then whichever function is encountered first, it will push it to the call stack, the top of the stack, right? Next, we encountered that console.log. It is pushed after that. Then we saw the function, which is called task1. We pushed it there, right? Now, whenever you are executing these things, right, you pull them out, you execute them, and that's it. That's how the language is internally working. So it's maintaining a call stack, putting things in a call stack, and then executing them and removing them. Are stack kind of array? No, stacks are a different class of data structures. At the end, the leaf was empty or null. It's not null, it's empty. So clear? Okay, great. So guys, when you are dealing with things which are going to happen sequentially or synchronously, right? You keep pushing things in the data structure or in the stack, keep pulling them out, and you keep running them, right? This is how the story of synchronous JavaScript happens, right? So basically, these are examples whenever the waiter is moving around collecting orders, right? It is occupied. The waiter is taking time to take the order, right? So it's doing everything sequentially or synchronously, correct? So this is the example of synchronous JavaScript, right? Now let's talk about how async JavaScript works, right? Okay, so I'm just going to give you a basic example where this actually becomes a problem, right? So let's say I was creating a website in which I do some sort of image processing. Okay, so I ask a user to upload an image, and I detect how many faces were in there, right? We can write code for that in JavaScript, believe me, right? So let me call that function as resize image, for example, right? So this is a function which takes in an image, right? And it does something with it, and finally returns something, right? So basically here is where you will have the logic of resizing that image, correct? Secondly, when you're done resizing this image, let's say you want to post this image, right, to your server, to your social network or whatever, social media or whatever, right? So imagine you say const post image. Again, you pass the image, and there is a network call. Of course, you'll have to send this over the network, right? You have to send this over the internet. So network access, right? And then finally it will get done, right? That's what we are trying to say. Now, after all of this is done, you want to say the user that, hey, success message, let's call it const success message. And this is something very simple. It simply says console.log image resized and uploaded. Right? Now look at this, guys. Please try to understand this. I say resize image first. I want to resize my image. Then I say post image. Right? And finally I say success message, which will just say everything is done. Do you guys understand this? People, is this clear? Right? Okay. Now, as we just learned, these three functions are going to get executed sequentially. So what JavaScript will do is it will first push this guy to the call stack, then push this guy, but it will push this guy only after this one is executed. Correct? Correct? Right? And then it will try to do this, and finally it will try to do this. Right? So guys, whenever you're trying to do these image processing or network requests, right, it's going to take some time, right? Depending on the complexity, depending on the network speed, lots of things, right? So, and only after you have done the resizing, can you post that image, correct? You can only post the image after you have done resizing it, right? And only after you have reposted and resized the image can you say, hey, user, we are done now, right? So basically what we have here is we have blocking code, right? Because one code depends on the other. And before the above code executes, you will not be able to execute this below code. Correct? Right, guys? Does everyone understand this? Okay. Do you have any questions, guys? I think you should. Guys, you should have some questions here. I'm just waiting for someone to write, to ask the right question. Is it code blocking? नहीं अमित, this is blocking code. ये code block करता है JavaScript की main thread को, हम ये कह रहे हैं. Right? Guys, अरे यार सबको अपना ऑपरेटिंग सिस्टम शो ऑफ करना है यहाँ पे. नहीं सर, कोई डेडलॉक नहीं है यहाँ पे. व्हाट इज डेडलॉक आकाश? डेडलॉक क्या होता है? Anyway, we can do some task between image resizing. You can't. No, Priyanka, that's not what a deadlock is. Anyway, सुनो यार अभी. Shivam, you are saying we can do some tasks between resizing. कैसे करोगे यार? You have only one thread. Here it's working. Here it's working. Only after you do this can you do this. So where is the question of between? हाँ शिवम. So no point of between. Repeat once. I just said this thing very simply, Jatooth, that there were three functions. JavaScript is single threaded. I executed them one after the other. They are going to block the main thread or the only one thread that JavaScript has, right? Because only after this thing has happened, can this thing happen? Only after this thing has happened, can this thing happen? So we are just slowing everything down, right? So what is the solution? Let's talk about it. Okay. The simplest thing that you guys need to understand is this. Okay. Let me explain that to you. Guys, before moving any forward, I would want to introduce two things today to you, right? Those two things are something called as setTimeout in JavaScript, and the other is setInterval, right? And we will understand how these things work. Okay. Okay. The first one, which is called setTimeout, works like this. So you say setTimeout, right? It takes two parameters, guys. It takes a function right? So I'll just put an anonymous function here in which I'm going to say console.log, right? And the second parameter it takes is the time. Okay, so let's say it takes 2 seconds. So I'm just going to write 2000 because it takes times in millisecond and not seconds, right? And when I press enter, what should happen? Can anyone tell me? Yes, after 2 seconds, you will see hello, right? It will wait till 2000 seconds. Okay, let's try that. I'm going to hit enter now. And after 2 seconds, it says hello, right? Or after 2000 milliseconds, it says hello. नहीं विशाल, चलाने वाला तो एक ही है ना विशाल भाई. You are saying you will ask everyone on table to give orders after 2 seconds, right? But there is only one guy which is going to take those orders, right? So no, please try to understand. What is 964141? Whenever you run setTimeout, it returns a timer ID. This is that timer ID. नहीं, epoch नहीं है RV. Epoch इतना छोटा नहीं होता. Epoch 8.9 से आता है. So no, but one thing that is worth mentioning here is when you do this thing, suppose you say setTimeout with an anonymous function. Inside this anonymous function, you are performing something. Right? Again, I'll just say hi in this anonymous function, and as a second parameter, of course, we take give time, right? So 1 second this time, or let me give 2 seconds only. In the next line, please see what I'm going to do. Here, I'm going to say console.log. Hello from outside. Okay. When I press enter, can anyone tell me what will get logged here? Okay. No. Okay, so Vishal says first this. Okay, basic question. Let me make this 1. Let me make this 2. Which is going to get logged first? 2 or 1? 1 or 2? Okay, how many say 1? Okay, 1. Cool. That's where the problem is, right? Let me actually show you the answer. We do this, first 2 gets logged, and only after 2000 milliseconds we see 1. Correct? So what actually happened, right? What is internally happening, guys, is when you put 2000 milliseconds here, it's not that the runtime or JavaScript is waiting for 2000 milliseconds, right? Because assuming this, if I wait for 2000 milliseconds, I'm completely blocked, right? I can't execute anything else. So I'm just going to put these here. When I write this, it's not that I'm going to wait for 2000 milliseconds and then do this. Because if I'm waiting for 2000 milliseconds, I'm going to lose out on a lot of things. What will I lose out on? Anything else, right? If you're blocked for 2 seconds, nothing else. Let's say there were 10 functions after that. You will not be able to execute all of those functions. Correct? Then how does this work? Right? So guys, this one thing is an example of asynchronous code. Right? So I'm just going to introduce these two to you today. One is setTimeout, the other is setInterval. And then how they internally work is something that we'll talk about tomorrow. Right? So we have setTimeout, and we know it basically executes whatever we say after this much amount of time, right? And after doing so, it basically runs this function, right? Second one is setInterval. So this is different in some sense. One is that it still takes a callback, which is going to get executed. And the second, of course, is the time. So let me say this is 1000 this time, right? And when I press enter, does anyone know what's going to happen? Okay, you know, then no worries. So I say, so I'm not doing anything, but after every 10 seconds, it's logging high. Do you see this counter increasing? After every 1 second, this function is going to run, right? So essentially it starts an interval timer. Right? And of course, I'm just going to clear this interval. Yes, it's like a clock. It will never stop unless you explicitly stop it. How do you stop it? First, it will also return an ID, which is this ID. I'm storing it in a variable which is called t, and then I'm calling clear interval on t. Yes, Amit, this is the thing which you use for creating those things, repetitive alarms and all those kind of things, right? So if you've seen on Google Docs, if you've not, after every sometime it keeps saying, it keeps telling you saved. So it's saving after every sometime, correct? That's how it's implemented. So they say set interval, and after every so much time, 3000 milliseconds or whatever, they keep saving that. Right? So this is how set interval works. Set interval also gives you a t, right? And not a t, it gives you an ID or the interval ID, which I stored in a variable called t. And when I want to stop this timer, what do? I say clear interval t. So these are, of course, these are things which are available out of the box. Set interval, right, is a function. Clear interval is also a function. Got it, guys? But none of them, right, they are somehow allowing us to write asynchronous code or non-blocking code is the point of the discussion, right? So set timeout does not block the next statement after it. Set interval, very similarly, will not block the next statement out of it. So it's not like when you're calling set timeout, you're waiting for those many seconds. Somehow, you spend after this much time, you run this function, and you can still continue the execution of whatever you're doing, right, without having to pause. So in some sense, we have written non-blocking code. This is an example of non-blocking code. So do we understand the difference between non-blocking code and blocking code, guys?